Think about the most complex object you know. A human brain, a galaxy, even a single living cell. Each is packed with staggering layers of detail. The human brain, 86 billion neurons, each with thousands of connections. A galaxy, hundreds of billions of stars, planets, nebulae, trillions of variables to describe it fully. But what if I told you that the most massive, terrifying objects in the universe, black holes, are also the simplest? Unlike anything else, a black hole can be described by just 3 numbers. No matter how a black hole forms, whether it's born from a dying star, grows by devouring galaxies, or even if you threw every book ever written into it, once it's a black hole, everything about it reduces to just 3 properties. Mass, how heavy it is. Spin, how fast it's rotating. Charge, its electric charge, though most are neutral. That's it. No history, no memory of what fell in. Just 3 digits. This is the black hole information paradox, one of the biggest mysteries in physics. If you toss an entire library into a black hole, all that knowledge, every word, every idea, is seemingly erased from reality. The black hole doesn't remember any of it. But how? How can an object that can swallow entire stars be so simple? Let's rewind. The idea of black holes didn't start with Einstein. It began with an 18th century English clergyman, John Michell, who asked, what if a star was so dense that even light couldn't escape? Using Newton's physics, he calculated a critical size where gravity would trap light forever. He called them dark stars. Fast forward to 1915. Einstein's general relativity rewrote gravity. Months later, Carl Schwarzschild solved Einstein's equations and found the first true black hole solution. His math revealed a boundary, the event horizon, where time and space switch roles. Cross the event horizon, and there's no going back. Time itself flows inward, dragging you toward the singularity, a point of infinite density where physics breaks down. But here's the twist. From outside, a black hole is just a hole. No hair, no features, just mass, spin, and charge. In the 1970s, Stephen Hawking made a shocking discovery. Black holes aren't completely black. They glow. Thanks to quantum mechanics, particle pairs pop in and out of existence near the horizon. Sometimes one falls in, and the other escapes. Hawking radiation. Over eons, black holes evaporate. But if they vanish, where did all the swallowed information go? The answer might be even stranger than fiction. The holographic principle suggests that all the information inside a black hole is encoded on its surface. Like a cosmic DVD where 3-dimensional reality is stored in 2-dimensional pixels. This isn't just philosophy, it's math. String theory calculations show that black hole entropy, a measure of information, depends on its surface area, not volume. If black holes are holograms, does that mean our universe is too? Some physicists think so, that reality might be a projection from a distant higher dimensional boundary. But for now, black holes keep their secrets. With gravitational wave detectors like LIGO and telescopes like JWST, we're peering deeper into these cosmic enigmas. Maybe one day we'll crack the code and find out what's really inside. Until then, black holes remain the universe's ultimate paradox, the simplest objects, hiding the most profound mysteries. What do you think happens inside a black hole? Let's discuss in the comments. Like, subscribe, and hit the bell for more mind-bending space content.